In chapter 2, we're going to begin by looking at different ways of visualizing and organizing our data sets. And then towards the end of the chapter, we're going to start looking at how to analyze numerical data to give us an idea of the center and the spread of data to distinguish two data sets. And then we'll begin analyzing it in later chapters. So to begin, a frequency distribution is a table that shows what are called classes, or sometimes you may hear them called intervals, of data entries with a count of the number of entries in each class. The frequency of a class is the number of data entries in that class. So if we look over here, this is an example of a frequency distribution. We have classes and we have the frequency. So the frequency distribution has 6 classes. Each class has what is called a lower class limit, which is the least number that can belong to the class, and an upper class limit, which is the greatest number that can belong to that class. Over here, for each one of these classes, the lower class limit is the number on the left. So we have 1, 6, 11, 16, 21, 26. Those are our lower class limits. And then we have our upper class limits, which are the numbers on the right-hand side. So 5, 10, 15, 20, 25, and 30. All right. So then the class width is the distance between the lower or upper limits of consecutive classes. So in this example, if you take, say, 6 minus 1, you get 5. If you take 26 minus 21, you also get 5. If you take 15 minus 10, you get 5. And so for this example here, the class width is going to be 5. The difference between the maximum and minimum data entries is called the range of the data set. And now, when we construct these things, we don't know exactly what the data values are, but we know how many are between 1 and 5. There's 5 data values between the numbers 1 and 5. There's 8 data values between 6 and 10, and so forth. So there may not be, say, a 7 in our data set, but there might be 4 6s, 2 8s, and 2 9s, which constitutes the 8 in the frequency distribution. So what we can do without knowing this, why don't we mix it up and say that our maximum data set or data value in this example is, say, 29. Right. If you actually had a data set, you would know explicitly what that data value was. Since we don't have an actual data set in front of us, we just have this frequency distribution. Let's just make an assumption just for fun. So the range is going to be our max value minus, and why don't we assume our min value is 1. So we'll do 29 minus 1, and that would give us a range of 28. So here are the guidelines for constructing a frequency distribution from a data set. So if somebody just hands you raw data, you can turn it into something that looks like that. First, we're going to decide on the number of classes to include in the frequency distribution. So the number of classes should be something between 5 and 20. That's what makes it manageable. More often than not, the question will explicitly say with 7 classes or with 5 classes or 6 or something along those lines. So you know where to begin on the number of classes. Next, we would have to find the class width. So to do that, we first determine the range, like we did here, the max minus the min. Then we're going to divide the range by the number of classes. Once we have that number, it's most likely going to be a fraction or a decimal of some sort. And what we're going to do is we're going to round it up to the next convenient number. Now that's very subjective. If our data values are all whole numbers, you'll want to round it up to the next whole number. If all our data values are decimals that go out to the 4th decimal place, you'll want to round it up to, say, the 3rd decimal place. Something that kind of parallels the data set that you're working with. After you find the class width, what we need to do is find the class limits. So using the minimum data entry as the lower limit of the first class, we add the class width that we found above to the lower limit of the preceding class. That will give us the lower limit of the second class, and then we just keep repeating that. Next, we want to find the upper limit of the first class. Then we want to find the remaining class, upper class limits. Once we have all of that established, we just go through and make tally marks for each data entry in the row of the appropriate class. Once you have all the tally marks written down, you just count up the tallies and create the total frequency F for each class.